license plate consists of 3 letters followed by 4 digits. Daniel does not want any letters or numbers repeated on the license plate. How many different possible plates could it be?
So how many digits on this one?
4.
We got 4. 4 digits followed by, what was it again? 3 letters. So it'd be 7 blanks. And he said he does not want any of them repeated. So how many letters in an alphabet do we have? 20, 26. Now, once I use that letter, I don't want to use it anymore. So do I still have 26? No, I now have 25. And then I've used those 2 letters. So it's 2 less than 26 is how many? 24. Okay, how many digits do I have total? 10, because we have 0 through 9, right? So we have 10. And again, he said, do not repeat. So the next one is going to be 9, 8, and 7. You simply take those and multiply them. Everybody type in with me. And make sure you're multiplying 7 values. It's going to be really big. That upper table, someone's not typing. Do we get something like in the millions? In the 1 millions or tens of millions? 78,624,000. That'd be nice if that's in your bank, right? Yep. All right. Let's go on to part B. Okay, Bryn, let's read part B, please.
Evan wants to build a sandwich that consists of 3 types of bread choices, 4 types of meat choices, and 3 types of spread choices. How many sandwich combinations are possible?
So we have the bread, the meat, and the spread. That's a boring sandwich, right? So how many types of bread do we have? 3. What about meat? 4. What about the spread? 3. Let's go ahead and multiply them. 3 times 4 times 3. Boom. 36. Are we good with that one? Okay? Okay, the next one, Nathan, let's read part C, please.
There are 52 playing cards and a dice numbered from 1 through 6. There is a probability of David rolling a number greater than the 2 and drawing a card.
So let's write probability of getting a number greater than 2. So I'm going to say n is greater than 2. And then drawing what suit? The heart. So if I want something greater than 2, when the dice is number 1 through 6, 3 is greater than 2. Did y'all realize I wrote 0? Okay. Something greater than 2. So we know 3 is greater than 2, 4, 5, and 6. So how many, is it 3? 3, 4, 5, 6. How many choices is that?
4.
Is that 4? It is 4. So we have 4 out of 6. And then how many suits do we have in a deck of cards?
4.
We have 4 of them. And we know there's 52 total, right? So how many would be the hearts? 13 out of 52. So we got 4 over 6 times 13 over 52. Again, I see some people not typing. Maybe I should take the calculator away from you on the test day, right? And I want this to be in fraction. So we have 1/8. Okay, are we good on that part? Okay? All right, the next part, part D. Okay, Adam, let's read.
It's 1/6.
Is it 1 over 6? It is 1 over 6. Ooh. Thank you. It did say 1 over 6 on my calculator, right? Sadness. Okay. Adam, go ahead and read.
In a class, 55% of students on a sports team and 35% of students are in the band. If 70% of students in a class on a sports team or in the band, what is the probability of a student randomly selected from the class and is in the band and on the sports team?
That kid was not paying attention. Okay, when I'm looking at percentages, I want to think about 100 students. Let's assume we have 100 students. So since we're looking at 2 different sports teams, is there a chance that some people might be playing both the sports? Okay, let's make our Venn diagram. So here I have, the first one is gonna be, we have sports and band. And there may be some people that are in both. So let's see what we can do. I'm gonna take the 55 plus the 35, and that's gonna give me how many? 90, but it says 70 are in one or the other. So that 70 is going to both of them. What this means is there's 90 activities that 70 students are doing, meaning from those 70, there may be some doubled up. Does that make sense? Okay? And the way to find right in between is this. You take total individual activities minus the total number of students being involved, and that's gonna give me the value right in the middle. So what is 90 minus 70? 20. There goes 20. So now let's go ahead and individually look at it. 55 are in sports. So we know from the 55, 20 are doing both. So that means the ones that are only doing the sports, it's going to be 35. Are we okay with that? 35. And then we have the band, it's going to be 35. So 35 minus 20 is how many? 15. And it says, what is the probability of a student randomly selected is in band and in sports team? It's going to be right in the middle. So our probability is going to be 20 out of 100. And that's going to give us 1/5. Are we okay with that? There's an algebraic way. There's also a way with matrices. Anybody want to see it that way? Are we good with the intersection? We're good with this way? Okay. Our next one. Okay, Chelsea, let's read our last one.
In an orchestra program, 80% of students are on a sports team and 30% of students are in the culinary club. If 85% of the students on a sports team or in the culinary club, what is the probability of the student randomly selected from orchestra is in both the sports team and culinary club?
Okay, let's do our Venn diagram again. So we have 80 are in sports, 30 in culinary. So I want to figure out how many individual activities. 100 plus 30 is 110. Does that mean that's 110 students or that many activities? That many individual activities. Somebody might be doubled up. But we know together 85% is going to happen. So 85 students is what I want to look at. So I take total activities, how many total students involved, it's going to give us doubled up one. So how many is that right when I subtract them? 20 how many? 25. So I know 80% are in sports. So what is 80 minus 25? Is that 55? Yes? And then we have, for the culinary, 30 minus the 25 is how many? 5. And I want to figure out how many are in both. How many are actually in both? 25? Out of 100%, we have 1/4. So again, y'all okay with this without algebraically or matrices?
Wait, so it's 85 minus the 25. How do you get?
No. Total activity minus total students. And that's going to tell me how many are doubled up.